Hi everyone, we are waiting for a few more folks to join in. So we've got a special guest today, Mr. Yan Chui. So he's gonna speak about his experience on building end-to-end product out of serverless as an architecture pattern. So before we move on, before we start, let's wait for a few more folks. Somehow I don't know, I'm not able to see live watching count. So if you guys are here, just say hi in the chat so that I know that people are here. Okay, I see 10 watching now. Okay, good to see that. Guys, just write hi, or if you are not able to see screen, if my voice is audible, just start writing messages. Yeah, Nilesh, I can see your message now. Okay, I think people are able to see us. Any problem with audio or screens or anything? Okay, good. Okay, let's wait for a few more minutes before people start pouring in, and then we'll start with the session. Okay, till that time, I see 11 people around watching the stream. Let's do quick question and answer stuff. Okay. How many of you have built anything with serverless till date? Just say yes in the chat if you have done that. Okay, I see a good amount of lag in my screen. Okay, Nilesh has done. Yeah, of course he has done. Who else? Who else has built a single serverless function? Till date, when it comes to serverless, Advait has done that. Okay. Who else? Danesh has done that. Okay. Only three people. Okay. Waiting for a few more folks to join in. By the way, I've changed a bit of setup, so you'll see me, seeing here and there. I've set up my second screen today, so I'm trying few more things when it comes to streaming. You'll see the upgrade on the video as well as soon as Amazon does the delivery. Yeah. Okay. Any more people? Anybody else has done anything with serverless? Just write yes and no in the chat so we know, how many of you have tried anything when it comes to serverless, typically, with Amazon Web Services. Or for that matter, anything like Google or Azure or anything. Naveen has done that. Okay. Andrew. Wow. Andrew, where you are from? Just write that into chat. Would love to hear some global people also joining us for our stream. Himesh Kumar has also built something with serverless. Good to hear that. Wow. So we have Andrew from London joining us. I believe it's afternoon for you. Okay, guys. So let's not wait any further. I wanted to introduce you, Mr. Yanchui. See, I've been trying to gather different real life speakers or persons who might have done anything with serverless, right? So we had Eric previously. Before that, we had Vishal. Now this time I've brought Yan. See, if I talk about Yan, he has done anything and everything when it comes to serverless. So you'll find his books. When it comes to serverless, he has a podcast running as in the name of Real World Serverless. He's been very vocal about implementing serverless across different domains and different architectures. uh, he's been working as a consultant or support to any of the enterprises who are looking out for support when it comes to building serverless infrastructures. He has his own company called the Burning Monk, and through which he does writing, he does speaking, consulting, and all that stuff. Okay, so let's not wait any further. I'll start with this session now. See, today's session, because of the time difference between us and Yan, he's gonna be with us little later today, like in the next half an hour. The session is pre-recorded, so this is something that I'm trying for the first time in our live stream. So bear with me if there are any glitches. I'm still 50 days old when it comes to live streaming. So I've recently started. So anything goes wrong, just let me know in the chat, and I'll try to fix it within the stream itself. So let's start with the session, and then let's start with this session. Just a second. Okay, I think Yan's session is available now. Okay.
Hi there, welcome to this talk on how we build a social network in the
Let me know if the voice is clear.
using serverless and GraphQL. So recently I worked on a client project where I built a backend for a new social network that lets you, mostly university students in Belgium, register your sporting interests and find other people to do sports with. You can arrange activities like a basketball match and have group chat, or you can message each other directly to arrange doing sports together. So in this case, the client is a privately funded, bootstrapped startup. So there's a lot of constraints on money and therefore development time, and that they also need to have something ready in place before the new semester starts, or was going to start in September. And so from the get-go, I had some really clear goals to work with to help me drive technology decisions and what approach I should take. We want to maximize the speed of development as the client needs to get the app out quickly and can't afford a really long development cycle. But at the same time, we need to have something that can scale to millions of users if this becomes popular and it takes off. They already have agreements with local universities in Belgium to roll it out to tens of thousands of students right away. And this is especially important because the first version of the app they built with PHP and running on 2 servers, it was a disaster and it crashed on launch day. So we can't repeat the same mistake here. The system also needs to require minimum upkeep because, again, the clients just don't have the funds to have a full-time development team to look after this solution. So the system pretty much needs to run itself and not fall under. And it also needs to be cost efficient as well, even as we scale to hundreds of thousands or maybe even millions of users. So the project was put together with a team of 3 engineers, including myself, where I was working part-time, averaging maybe 2 or 3 days a week for the couple of weeks, while I also work with other clients and had other responsibilities as well. So we didn't just build a mobile app, we also built a CMS for the app as well, which will be used by the founders to onboard new universities and to manage a list of predefined sports that you can select from in the app. The CMS will also be used by university staffs to manage their profile and to publicize their sporting programs. So I'm not going to show you the full architecture here, but here are just a few of the key components. We have CloudFront and S3 for image assets and search. And as for authentication, we use Cognito. There's one Cognito user pool for the mobile app, and then there's another one for the CMS. And the backend is all done in GraphQL using AppSync. Again, one for the mobile app and one for the CMS. And they each have resolvers that will point to DynamoDB for simple get and put, and the query operations. For anything more complicated than that, I will have a Lambda function resolver, and that function might also be doing something against the DynamoDB, but typically something more complex. And you can also use pipeline resolvers instead of Lambda functions for a lot of this, but it's just easier for me to do it with Lambda and easier to hand it off to someone else later without having to force them to learn about pipeline resolvers as well. We also use Algolia for search, and for those of you who are not familiar with Algolia, it's basically Elasticsearch, but it's probably the closest thing we have to a serverless Elasticsearch, so that to get the data into our Algolia indices, we use the DynamoDB stream to trigger a Lambda function to then synchronize the data changes to Algolia, where a user would create and update their profile, and they maybe add the new sporting activity in the app, whereby they will organize a basketball match for next week, for example, so that other users can then find those apps, find those activities in the app with our Lambda function resolver, which then goes to Algolia, do a search, and return to them the UI. And I also capture BI events from the different Lambda functions and use a Firehose delivery stream to buffer and to batch them into files into S3. And so we can then run business intelligence reports against them using Athena. Again, this is not the full architecture diagram. It's just a summary of the different services I used and how they kind of fit together from a high level. And if we move a level up, we have multiple AWS accounts, which is a good security practice, and it helps limit the blast radius of any security breach. And it also gives you consolidated billing and the billing report across all the different accounts. I use the AWS organization and for managing these accounts, and I had the 4 independent organization units for dev, staging, production, as well as an org unit for accounts, for shared accounts and managing shared resources. For example, there's a user's account set up specifically for single sign-on, and a shared account for collecting all the information, such as CloudTrail logs and so on, from all the different accounts. And at the organization roots, I have a couple of service control policies, for example, to deny access to all services outside of EU West 1, because I know for a fact that that's the only region we're going to use for this particular app. Again, remember, all of this was done by a single person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants. And really, all the hard work here is done by AWS and the different service teams, and I can rely on the good tools like the Serverless framework to help me manage and deploy my application. So my name is Yan Cui. I'm an AWS Serverless hero, and I am also a long-time AWS user. I have been running production workload on AWS for over 10 years now, and the last couple of years I have focused on the serverless space, including migrating a social network, a completely different one, to run pretty much entirely on serverless as well. And that was in 2016, and I wrote about that experience in a series of blog posts that you can read on the link down below here. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications where you have a single place you can go to see all of your traces or all of your logs, and you can see them side by side as well, which really helps you debug different problems that can occur in your serverless application. The other half of my time, I work as an independent consultant, where I work with clients from all around the world to help them go faster for less by adopting serverless technologies successfully. I provide them with training, with advisory, but also sometimes working with clients like the one I talk about today to deliver an MVP for their product. In my spare time, or whatever little time I have, I try to write. I do a lot of blog posts, and I also work with people like Manning Publishing to publish video courses and books, and also self-publish a couple of courses as well that you can check out there. And recently, I also started doing a podcast called The Real World Serverless, where I speak with other people that are using serverless technologies in production and try to get their stories out so that we can all learn from each other. So that's it about me. Going back to the topic on hand, I'm sure most of you are familiar with GraphQL already, or at least you have heard about it. So I'm not going to take too much of your time here. So essentially, GraphQL has a schema language that allows you to define data types and operations that you want to support, including queries for fetching data and the mutations for, well, mutating data in your system. The client is going to send a query or mutation to a GraphQL server, and Apollo is probably the most popular implementation for a GraphQL server. And the GraphQL server itself is going to validate the request against the schema, parses them, and then in turn, it's going to fetch data from different data sources and stitch them together in the format the client has asked for. So think of it as your backend for front end, except you don't have to write bespoke endpoints every time the client wants another piece of data or it wants them in a slightly different format. And as for AppSync, it's basically a managed GraphQL server, which lets you map those queries and mutation operations, as well as the data types to different resources, to map them to different data sources in your AWS account. Right now, it supports DynamoDB, Lambda, Aurora, RDS, Elasticsearch, as well as raw HTTP endpoints out of the box. For example, as a user, I need to fetch my profile, and in my query operation, I'm able to fetch everything I need in one query, including my ID, my first name, last name, gender, and the sports that I'm interested in. These are all mapped. So this is mapped to a profile table in DynamoDB. So AppSync will fetch my profile using the authenticated user ID that Cognito has provided to AppSync. But in this case, the list of sports that I'm interested in my profile only contains the ID for the sport, because we want to be able to change the name of the sport or the image we associate with the sports, and we don't want to break them into every single user's profile. So we're going to have to expand this sports IDs and fetch the image as well as the display name for each of the sports that I'm interested in. So within GraphQL, that's called a nested resolver. And in this case, AppSync can then fetch those information from the sport table in DynamoDB. So we're all good here. There's no need for the client to send two separate requests, one for the profile and then one for every single sport ID. So it helps us save some additional round trips here. And as for my activities, since I can have many activities, so when I fetch my profile, I just need the first page of it for my next set of activities. That's most likely all I care about in terms of what are the next activities I have. And if I want, I can scroll down to fetch more pages of activities so that I see the activities I had in the past as well. So AppSync runs a query, in this case, against the activities table, where the data is stored with my user ID as the hash key and the timestamp for the activity as the range key. So we can easily get pages of activities in descending order chronologically. And since other people might ask to join my basketball match next week, for example, I also want to fetch any requests from other users as well. Again, we only store the user ID in those requests. And to display this request in the UI, we also need to expand this into the user's public profiles as well, including their name and image. So we can get those from another nested resolver, and then AppSync is going to again fetch those data from the profile table for those users who has asked to join my activities. So as you can see, this is all very flexible. The client can basically ask for any information that they need, but you can probably also sense the danger here as well, that the client might end up just asking for a lot more information, and you can have this really deeply nested queries that can start to impact performance because you have all these nested resolvers that may have other nested resolvers as well. So it can have a really big impact on the overall performance, but also on the cost you have against, say, DynamoDB. So luckily, you can mitigate some of this by enable caching in AppSync, which lets you cache which allows you to enable caching on specific resolvers. And you can also adjust the cache TTL for each resolver as well. So maybe for the list of sports, they don't change often, so you can have longer TTL on those cache compared to someone's public profile. And to prevent the further nesting and to prevent the leaking personal information like date of birth, there's a separate data type for your profile, which only you can fetch, and your public profile, which other people will be able to load when they find you in the app somehow through search or through looking at one of your activities, and then linking that to your profile. So for your public profile is a much flatter structure that doesn't allow for much more nesting after that. So that in this case, one query is able to return all the data I need to display my profile in the UI. And when you see other people's profile, you're looking at the data that's available through their public profile only. So you won't be able to see more personal information like date of birth, for example. So AppSync itself is very, very scalable. The GraphQL subscription implementation can support millions of connected clients concurrently. And your AppSync API is also deployed to multiple availability zones out of the box, which gives you a really good baseline in terms of resilience. And the great thing here is that you only pay for what you use at $4 per million operations. And as I mentioned earlier, it also has got support for built-in support for caching, which does charge you extra. It's essentially you are now going to be paying for uptime for a memcached node. So how much you pay extra for the caching depends on the size of the cache node that you want to use. It has also got support, built-in support with monitoring through CloudWatch and CloudWatch logs, where you can get high-level metrics like the number of API requests, error counts, and latency, which is great. But unfortunately, all of those metrics are aggregated. So it's difficult to tell that when there's a spike in latency, for example, which resolver is the problem. Since a single query can involve many different resolvers and some may return faster than others, and you can't tell from looking at metrics alone what actually happened. So luckily, you can also enable logging in this case, which can give you a lot more information about what's actually going on under the hood. So you can at least narrow it down to specific requests that took a long time, and then inspect the resolver logs for that request to figure out what the problem actually is, which resolver is is responsible for this spike in latency. But for performance issues like that, I think it's even better if you use if you enable and use X-ray, which really shines a light into what's actually happening under the hood and shows you where the time is taken. And you can see in this case that from a single GraphQL query, it resulted in quite a few different DynamoDB database calls behind the scenes. And X-ray also shows you this service map, so you can get a high-level view of what services your AppSync API is talking to and their overall health, but also overall health, average performance, latency, and so on as well. And it gives me all of this, and I don't have to manage any servers at all, which is amazing. So in general, everything has kind of just worked as advertised, but I did run into a couple of very small things, which I've also written about. For example, there was an issue with the documentation around how to handle conditional errors with the DynamoDB resolvers. The documentation was just wrong, but it's been raised. I've raised it to the team, and the AppSync team is looking into changing the documentation. So in the meantime, if you need to know what you need to do for that, I've got a blog post for you. So check out the link afterwards if you want. And it also wasn't clear how I can skip those nullable fields when it's a nested resolver. So again, I wrote a blog post on how you can do that. So some of you may have also noticed that I have got quite a few different DynamoDB tables. Actually, I think in the end I had about 14 or 15 different tables. And if you've been following what's happening in the sort of DynamoDB space, you might have heard about this whole single table design thing and wondering why I didn't condense some of these tables into single tables. which often can offer the best performance, scalability, but also possibly cost as well. But for this particular app, I don't need to optimize for the best performance or scalability, and the multi-table design would be sufficient, at least for the foreseeable future. And the thing with I find with single table design is that it's also much more complex and requires a more thorough understanding of how DynamoDB works, especially in terms of the global segmented indices. Now, I don't remember who said this, but it's my preference to design my system as if it will be run by idiots, because one day it will be. And most of the time, that idiot is yourself in 3 months' time. In a world where, so if you live in a world where most developers are familiar with single table designs, then I will gladly choose a single table design for all the technical benefits that I mentioned that you can potentially offer. But until then, I want to do the right thing for the client and build a solution that somebody else can more easily take over and carry on after I leave the project. But as a member of the AWS community, I do want to see more people adopt the single table designs because it does offer some really good benefits. So if you want to, so I do implore you to learn more about it. Maybe start by watching this session from Rick Houlihan at the reInvent 2019, but also check out Alex DeBrue's excellent DynamoDB book, which will help you get the most out of DynamoDB, including many advanced modeling patterns and useful tips and tricks as well. In terms of the authentication side of things, as I mentioned earlier, we use the Cognito user pool, and I set up identity federation so that users can also sign in using Facebook and the Apple ID as well. And on the client side, we use the Amplify JavaScript library to integrate with Cognito, which makes authentication and other things like that really quite simple because it gives you a lot of the helper library, helper functions, and also you manage the refreshing tokens and things like that out of the box. However, I didn't use the Amplify CLI to create and configure the Cognito user pool or the DynamoDB tables and things like that. I did them by hand because, well, I know how to do that quite well. And if anything, I want to know what's happening, what's being configured intimately. And with the Amplify CLI, I think it's evolving very quickly. But I also heard the reports of breaking changes, and that's not something that I'm willing to deal with on a client project, where the goal is to be able to hand this off to as a solution to somebody else later. And while I think the Amplify CLI is great for quickly bootstrapping a new app, especially for a team that doesn't have a lot of experience with AWS and with Cognito in general, in particular, it really helps you sort of get something going quickly and to give you some good defaults. But I've also heard that it doesn't cope very well with certain changes. And a few people told me that they've had to delete the entire stack when it got stuck and they can't apply some changes. Again, probably because limitations with CloudFormation under the hood, or because the tool is still relatively young and still maturing. But again, it's not something that I want to deal with for a client project where we have really tight deadlines for delivery. Now, Amplify can also provision and actually configure the DynamoDB tables for you as well, including the AppSync resolvers, which is great if you want to, again, just push up something quickly. But I also find myself not agreeing with some of the decisions that it takes. For example, how it defaults to using DynamoDB scans for list operations. And in this particular case, the DynamoDB schema and the access pattern are really important here, with potentially huge scalability and cost implications. So I want to have tighter control around those, and I really need to understand my access patterns intimately to make sure that I'm doing the right thing in the table design, but also in my resolvers as well. Oh, right, and don't forget, we also built the CMS as well, which also uses the Amplify JavaScript library to authenticate users to the CMS Cognito user pool. And as an admin for the app, which would mostly just be the two founders, they can onboard new universities and configure the default list of sports that you can see in the app. But when you onboard a new university, you can also invite an admin staff from the university to the CMS as well. And we would generate a temporary password for them when we register the user in the Cognito user pool, which is all done by a Lambda function behind the CMS AppSync. the user is then able to log into the CMS, and they'll be asked to update their password on the first sign in, which is also done by Cognito. And the CMS user that we created for them in the CMS Cognito user pool will be added to a particular group called the university to identify them as the university admins and not the system admins or super admins, which will be the two founders. And we also use a custom attribute to tell us which university that they are the admin for, which is passed along to our resolvers by Cognito when the user interacts with the CMS AppSync API resolver. So at no point does the client then pass the university ID to the backend to say, oh, hey, I'm the admin for this university, trust me, and let me access the data. No, we always go by your identity, the university ID that is associated with your user. So you can't just mess around with the GraphQL query and gain access to data that you're not supposed to be able to see. And when you're the admin for university, you have different options in the CMS, which are limited to just your university. And the nice thing with AppSync is that you can restrict access to operations using Cognito groups. So if you are the admin, you'll be able to get university details by name of the university, and you can add to the list of sports we have in the app and so on. But these are elevated privileges that are only available if you are the super admin, which are the two founders. But if you are the university admin, then you can only fetch and edit information about your university and nobody else's. And in this case, in our AppSync sort of GraphQL schema, if you don't specify any specific authenticate options, then any logged in user can perform these actions like getting an upload URL for images and so on. So moving a little bit closer to the actual code, I use the serverless framework to help me package and deploy the application because it's a mature framework and it's got a great community around it. And it's also very extensible through this whole ecosystem of different plugins that are coming from the community. And we are going to see two of them in a minute. And also lastly, I'm also very familiar with the server framework. It's my go-to option for a few years now, and I'm very proficient with the framework as well. And in this case, I've got one repo for the whole backend, and everything is configured in one server YAML and is deployed as a one CloudFormation stack. So all the resource references and all of that were very straightforward, even as the project grew and grows. And to deploy, I have just one command that I need to run to sort of say deploy my entire backend. And to make it easy to figure out all the different resolvers, to configure all the different resolvers I had with AppSync, I use this plugin called Serverless AppSync plugin, which really made things easy for me. And as I mentioned, I have the two AppSync APIs, one for the app and the one for the CMS. So I broke those into their own files to keep things a bit more manageable within my server, so YAML. And each of those files is going to look something a bit like this, where I configure it and to use the correct Cognito user pool. Remember, we have two, one for the app and one for the CMS. And then I'm going to configure logging. So for production, I don't want to log everything because it's going to generate so much logs in CloudWatch, and that has got a cost associated with that for the amount of data CloudWatch logs process, but also for data retention as well. And then I will configure my resolvers and the data sources in the same file. For many of these resolvers, we will be going to DynamoDB from AppSync directly. So the request and response templates will have to be written in the Apache VTL, which is the same templating language that the API Gateway uses as well. So I'm kind of familiar with it already. And honestly, the official documentation does such a good job, and it gives you a whole bunch of different examples that you can pretty much just copy and paste and then change the bits that you actually need so that you can, so that is specific to your table and your resolver. And as the project grew, I hit the 200 resources limit with CloudFormation pretty quickly. since I also try to follow the principles of least privilege, and which is the golden rule when it comes to security for your Lambda functions. And I will have an IAM role for every single, so one IAM role for each Lambda function. So it didn't take me very long to actually get up to 200 resources. Luckily, there's this split stacks plugin, which lets you split your one stack into multiple stacks by splitting them, splitting some resources into nested stacks. And the great thing here is that it lets me control the splitting logic myself, which was very handy because remember, I have two AppSync APIs, each with its own cognito user pool and its own set of resolvers, and they're pretty much independent from each other. And I wanted to split them by the AppSync API that the resource belongs to, whereby all my shared resources like DynamoDB tables, S3 buckets, and some of the Lambda functions that are not part of the AppSync API, like the function that I had for processing and synchronizing data in the background or to send them to Algolia and so on. Those are all in the parent or my root stack. And all the functions, all the resolvers or AppSync resolvers and the corresponding IAM roles for those Lambda functions, they all split into nested stack. As you can see, there's quite a few more things in the application stack compared to the CMS stack here. And the great thing about all of this is that I can still reference DynamoDB tables and other resources in the parent stack for my Lambda function, which is then moved to the nested stack as if they were in the same stack, because the split stacks plugin passes them around as the parameters to the nested stack. So there's no code change required on my part when I decided to split up the stack from one stack into multiple into the root and then nested stacks for the AppSync APIs. So that brings me to CI/CD, and since the whole code base was in GitLab already, I decided to just use the GitLab CI/CD. And the one technique I have been using for most of my projects is to install the server framework as a dev dependency to the project, which means that I don't have actual dependencies on the CI server itself. And I can add a helper script in my package.json so that whereby when I want to deploy from the CI server, it's literally a two-step thing to run npm CI, which restores my dependencies to the exact version that they were specified in the package.json. And then run npm run SLS to run the SLS script, and then pass in the deploy as command to trigger deployment using the version of the server framework that's been installed in the project. But to do this, we still need to have our AWS credentials to run our deployments, right? And a really common question I get is, well, how do I secure my CI/CD pipeline itself, especially when I'm using third-party CI/CD tools that where I need to take some credentials, AWS credentials, and then put them into environment variables and put them into some kind of a secret vault. So far, the best approach I've seen is assuming that you have multiple AWS accounts. Say you have one for every environment. And then what you can do is that you can create a dedicated ops account where you run all of your ops or security monitoring tools there, and such as AWS config, security hub, and things like that. And you set up a CI user which has no local permissions in that account. Basically, you have a flat out deny on all actions in that ops account. But in each of those AWS accounts that you want to deploy stuff into, these are your destination accounts. You have, in this case, you have a deployer role, which is this CI user is allowed to assume. And each of these deployer roles will have an entity trust relationship to this CI user in the ops account so that they can only be assumed by this user and this user only. So even if the credentials for this user is somehow leaked or got stolen, then the attacker would not be able to do anything inside the ops account. And in order to do any damage, they will have to know, they will need to know the account ID and the role name for each of the target roles as well. So this way, you can have a very permissive deployer role and still be safe in your CI pipeline because they can only be assumed by the CI user, which on its own has no permissions whatsoever in its own account. But if you want to add another layer of protection, then you can consider using attribute-based access control (ABAC), where essentially you can further limit access to resources by tags. But problem is, right now, many of the AWS services that we use just don't support it yet, including Lambda functions. So that brings me to testing. And one of the challenges with using something like AppSync is that it's a bit of a black box, and how to even test it locally. There are tools that simulate the AppSync locally, but I generally don't bother with them as they don't cover everything, including IAM policies. And honestly, writing those VTL templates, they're so simple. They just work. You mostly just follow the template that's out there in the AWS documentations. Where it tends to go wrong are things that I'm doing in my Lambda functions, where I also tend to be doing things that are more complex or anyway. And for those Lambda functions, I want to test my integration with other services like Algolia or DynamoDB. But in that case, I can do that by executing the functions locally, but talking to the real DynamoDB table or Algolia. I don't tend to use mocks or stubs for DynamoDB tables or Algolia, things that I depend on, or I try to simulate them locally with things like local stack or DynamoDB local. What I find is that those kind of local simulation tools, they take too long to set up, to have them working properly, and they're quite brittle as well. It's just often far easier to provision the tables or indices in Algolia and just use them in my integration tests. And then I also have end-to-end tests that will run user stories, like user comes in, creates an account, creates a profile, does a search, and then joins some other users' activities and so on. And I'll run this against the deployed GraphQL endpoint. So this will always be run after the deployment. And if you have any failed end-to-end tests, then great. Use this as a valuable rehearsal for how to debug real problems in production. If this is difficult, then guess what's going to happen when you do have a problem in production once the system is live? Use this as a signal that use the difficulties you have as a signal that you need to improve your logging, how you're monitoring the system, and maybe enable X-ray tracing, enable more detailed logging. And if you're struggling to debug problems in a controlled environment like your end-to-end testing, then you're going to have a much bigger problem when this thing is actually running in the wild. So don't optimize for your comfort with all these local simulations. It's going to give you a false sense of security. And finally, let's talk about the AWS organization setup. So as I mentioned, I had several org units and AWS accounts within them. And I don't want to manage all of this by hand. I want to have infrastructure as code for all my things, including my AWS organization. So it's not supported by CloudFormation out of the box, but luckily there's this tool called OrgFormation, which gives me exactly that. It lets me provision and manage my entire AWS organization with infrastructure as code using a YAML-like syntax, which is very similar to CloudFormation. It makes it easy for me to template my landing zone as well, basically the sort of basic infrastructure that should be deployed and provisioned in the new account. Things like KMS encryption keys, default VPCs, and things of that nature. So in this case, I was able to declare a master AWS account and the root for my AWS organization. Again, this is all done in code using a syntax that's very similar to CloudFormation. And I'm also able to provision a new AWS account and set up budget alarms with just a few lines of code. I can also attach these accounts to my org units, which I can also create in code, and I can configure service control policies or SCPs. For example, here, I know the only region I'm going to use is EU West 1, so I can set up a service control policy that denies all actions against the regions other than EU West 1, and apply this policy to the organization at the root so that it's applied to all my AWS accounts. I can also configure my password policy for AWS users and use this policy in all of my AWS accounts as well. And whenever I make any changes, and I just need to have run this one command to update my entire AWS organization. For example, to add the new SCP rules, SCPs, or to add a new AWS account and so on. In terms of configuring my landing zones, I can configure what is called a task, where I specify essentially a CloudFormation template and provide a binding to my organization, which basically says which resources from the template should be created in which AWS account. By binding the resource to org units or specific AWS accounts. And here's an example of one of these templates where I have just a normal CloudFormation resource for an IAM user, but I can bind this resource to a subset of AWS accounts in my organization using this organization binding, which in this case allows me to filter accounts by org unit or account name, or even by tags as well. And down below here, you can see that I'm iterating through the AWS accounts that's been bound by the organization binding above. So don't worry if the mechanics of how this actually works looks a bit alien to you. Once you spend a bit of time with org formation, this would all start to make a lot more sense. And to update my landing zone, I just have to run another command to run all of these tasks to provision the CloudFormation resources in different accounts, maybe to add a new IAM user or user group and things like that. It's a really, really powerful tool, and I recommend that you check it out. It's available from GitHub and is maintained by MoneyU, which is a bank here in Netherlands. And that's kind of the three main tools I've used in this project. The server framework for deployment automation, AppSync for manage the GraphQL server, and automation for automating around the entire AWS organization. So if you go back to the goals that I started off this with, in terms of speed, I mean, getting everything done within just a few weeks is pretty good, considering the amount of work that's involved. And I was the only one working on this, and I was doing part-time on this as well. So speed of development, check. AppSync can scale to support millions of users, absolutely no problem. So again, check. And in this case, I had 0, big fat 0, EC2 instances. So no servers to manage whatsoever, and no networking, no VPCs, and none of that. So minimum upkeep, check. And with AppSync, Lambda, and DynamoDB, our entire stack is pay as you go, and the cost per million request is just a few dollars. So the projected cost for this, when we go live, even with tens of thousands of users, will still be relatively small, even if everyone uses the app a fair bit, because also we're going to have caching enabled in production. So being cost efficient, check as well. And that brings me to the end of this talk. I want to thank you guys very much for your time and for being with us this afternoon. As I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how serverless can help you go faster or need some help upskilling your team, then let me know. Go to theburningmonk.com/hire me to see how we can work together. Yeah.
Okay. That was a very insightful talk. Yeah.
Thank you.
Can you hear me well?
Yeah, I can hear you.
Okay, good to hear that. Fine. So thanks a lot again for spending time and helping us to gain this knowledge. Okay, and I've got good amount of thoughts after seeing your session and the way you had designed and deployed the overall solution. We've got one question so far, but before we jump onto that question, I want to ask one thing, which is there in back of my mind since I heard the name the Burning Monk. Okay, so I want to understand the story behind this name.
So I'm a big fan of Rage Against the Machine when I was growing up, and on the debut album, they had the Burning Monk, who was this monk, Vietnamese monk who set himself on fire in protest of the, I guess the north-south divide in the Vietnam at the time because of the U.S. influence and all that. I'm a big fan of the band, so when I came to pick an email address, I picked the Burning Monk, and that kind of stuck. So yeah, still using it nowadays.
So how many years you've been using this email now?
Can't remember since I was in school.
Okay, good to know that. Fine. So I when I search for the Burning Monk, all I see there's an old movie, right, which talks about the Burning Monk. But anyways, yeah. Coming back to serverless part, yeah. Sorry.
Okay, go on.
Okay, so we've got one question from Raja. He's saying how many serverless functions you had written and how to debug them. Do you recommend serverless for enterprise, high commercial value solutions of startups when they wish to scale to million of customers?
Yeah, sure. I guess that's really three different questions. We support three different questions. So maybe starting from the first one. For this particular project, most of the resolvers are just direct from AppSync to DynamoDB. I mean, if you can avoid writing a Lambda function with AppSync, you should just avoid it because there's less things you got to pay for. It's faster. There's no co-star. There's no anything like that. So if you can go from direct from AppSync to DynamoDB, you should do that. But as I mentioned, some of the operations are a bit more complicated. So I do prefer to have a Lambda function in there so that it's easier for someone else to look at the code later because it's just, maybe, I don't know, 50 lines of JavaScript code versus a lot of VTL. VTL is not that well, I guess, understood by a lot of developers. If you come from Java, maybe you've done some VTL in the past, but it's a really old technology, and I guess a lot of people just don't know VTL. So anything complicated, I prefer to do that in a Lambda function so that it's easier to hand it off to somebody else. The second question was how do you debug them? So when I write my I typically write integration tests whereby I would invoke the function locally because it's just a one block of function, right? That takes the event and take a context. Just invoke the function locally on the CI server or my laptop, and then have it talk to the real DynamoDB table or whatever, and then make sure that the logic is working. Make sure that the integration is correct. Like for example, when you're doing a DynamoDB query, your query syntax, all of that is right. And then after I deploy the whole thing, I have a GraphQL endpoint I can call. So I will also write end-to-end tests after that, and then that will execute the GraphQL endpoint, which is going to call my Lambda function and everything else, including incognito and things like that. So I do test them both as integration, and then before deployment, and then as end-to-end test after deployment. Third question is, do you recommend the serverless for enterprise high commercial value solutions or startups that wish to scale to millions of customers? Absolutely. I mean, with serverless technologies, you get a lot of scalability out of the box. You also get a lot of resilience out of the box as well. With Lambda, everything is deployed in multiple AZ. You don't pay for those redundancy, but you get them out of the box. And also with Lambda, you don't have to worry about a lot of the failure modes. For example, individual servers dying or processes dying, and have to do something yourself to recover from those failures. You get them out of the box. In fact, a lot of the infrastructure failures that you have to deal with and pay for because of the extra redundancies, you just get them out of the box. And you get the same thing with AppSync, with API Gateway. So any sort of serverless solutions you get from AWS, you should use them as much as possible because A, it gives you a lot of velocity, and also B, it gives you probably better scalability and resilience than you can do yourself. And unless you're doing really high volume traffic, high traffic system, you may also find it to be a lot cheaper compared to what you build yourself as well. So certainly, you look at the companies all around the world that are doing serverless in production.
at the very high volume systems. You've got companies like iRobot. They got tens of millions of robots all around the world. That's all done. That's all Lambda behind the scenes. From the robots sending messages to IoT core to triggering Lambda functions to do stuff. And then you've got companies like Basel who are doing something like 80 million monthly users. Everything is serverless for them as well. And also, you've got banking companies like big enterprises like HSBC in the UK, Capital One in the US, all using serverless very, very heavily as well. So yeah, serverless has been adopted very heavily across the spectrum. I think from what AWS tells me as well, there's probably even more enterprise adoption of serverless than there are for startups.
Correct. And just to add, see, when we talk about enterprises, usually those apps are not 24/7 kind of an environment, right? So enterprise could save a lot when it comes to costing when you don't have when you're not paying for that idle time, right? When you deploy in terms of servers and everything, you are paying for that infrastructure whether somebody is using it or not. But when it comes to serverless, you are just paying for what you're using. So that's anyways going to help a lot of enterprises when it comes to this. Okay, so we don't have any other question. Yeah.
Sorry, on that.
Yeah.
Yes, you will be saving a lot of money in terms of the operation cost, but the biggest saving is not in the how much you pay for your infrastructure, but it's in productivity and in the staffing, especially for enterprises. I saw some study, not recently, I guess, a while back now, from that got published on AWS in terms of some analysis on enterprise adoption of serverless. When you look at the actual total cost of ownership and the saving there, most of that is coming from staffing. So needing fewer people and the fewer, I guess, layers of bureaucracy that you have to go through to get something done. It helps you massively in terms of reducing your cost. Now, your cost for AWS may be 10 grand, but if you look at the people you have in the office, that's easily 500,000 a month ahead per person, especially in the US for areas like New York. Engineers are so expensive nowadays that if you can reduce just your headcount by a single person, that is tens of thousands of dollars per month. So in terms of serverless and the sort of value to enterprises, the biggest saving you're going to get is in staffing, not in the operational cost. Sure, you may save some, but those will be pennies compared to what you save by letting the people you have be more productive or just have fewer people.
Correct. That's like much more saving than having server spendings. Anyway, so I like after going through your sessions, one thing that you mentioned is whenever we are developing something with serverless, we should spend less time or no time at all figuring out how to do a local development setup, and we should push everything to, for example, AWS when we are using AWS, and we need to run the overall stack there and do all the integration testings and everything there. I have one question in that is, I see a risk. Me being entrepreneur, I try to reduce how many people would have access to my AWS accounts, because one fine day a new person comes in and tries to deploy something which would come in terms of last when it comes to costings, right? So what was your what was your experience when you tried deploying local stacks? Because that's something that, yes, I agree, it's been difficult for us as well to deploy local stacks here and there. For example, when I started using local stack, we used to use Lambda layers. Now you cannot run Lambda layers in a local stack if you don't have a pro package of a local stack, right? So what do you think, like in terms of costing, how do we make sure that we don't overshoot those aspects when we give access to a developer?
You use different accounts. You got a new developer come in, give him an account, or to have your developers per team have a separate dev account for that team. And then every stack that someone deploys, make sure that the tag with cost center, with the team name, with maybe the person who's deploying the stack, so that you can use those tags to do cost tracking. So if it's cost you're worried about, easy, set up budget on your AWS account, and that's it. You get alerts when those resources, when your account starts to get more expensive. So if you think how much time you waste trying to get local stack working the first time, and every time it breaks, and then you have to spend time to fix it, that's money as well. That's money, just as whatever money you see on the AWS bill when someone is doing something wrong. And unlike the productivity cost, the market cost, you can easily measure how much and warn yourself and alert yourself when your AWS bill is going up. So I think the economic is just not there for you to worry too much about. Oh, we're paying $100 more this month because someone creative provision something. Especially with serverless, where when something doesn't run, you don't pay for it. So you can have hundreds of functions. So it doesn't matter. It's not going to cost you anything.
Understood. So, when it comes to serverless, the product lifecycle becomes different, right? So usually we test before we are deploying. Now in this case, what happens is we need to deploy that first, for example, in developer stack, and then we need to run the test cases, and then we'll get the results, right?
Not necessarily. So like I said, for my integration tests, I run them before I deploy. So I run my integration test to my functions before I deploy them, and then I run the end-to-end test afterwards. So I do both. But I do so if I'm creating a new feature that uses a new database table, for example, then yeah, I do provision a table ahead of time so that I can run my integration tests. But those only done in the sort of dev environment. So typically you will have different environment, different accounts for dev, which is basically just for the team to mess around doing their own things, and then you've got other environments where different teams integrate with each other's services, like test and staging. So those I don't run integration tests because that's basically testing my logic, my code. And so those are just done in the dev environment. And after that, for the other environments, it's just double checking that any sort of environmental issues are flagged, so that if there's some implicit dependencies on the other resources within the account, things like that. So end-to-end tests are going to catch those for you. But for the lot of test your code before you deploy, that I do still, but only in the dev environment.
Understood. So we've got one question coming in from Mr. Mood. He's asking how to avoid pushing requirements every time instead of just push the code which we changed into Lambda. Yeah, same here. I think he meant that we deploy the whole Lambda function all the time rather than pushing the only change. If I'm not wrong, that's the question, Mr. Mood.
Okay. So rather than deploying the whole stack, just change the function. Okay.
No, I think he's going another one level. What he's asking, if I'm not wrong, is whenever we do deployments, the whole Lambda gets deployed rather than the incremental changes. For example, if you have 100 lines and you just change 2 lines in it, he's saying why we are not deploying only 2 lines in it rather than deploying the whole 100 lines.
Sure. I mean, with the same things like the serverless framework, you can also deploy individual functions, but you wouldn't want to do that from a CI/CD perspective. There's also things like config changes. Well, sometimes config can change, and all of that as well. And also, if you're using CloudFormation, CloudFormation works out what's changed anyway. So with other resources like tables and things like that, if they haven't changed, they don't get updated. But your function will probably still get deployed. But in this case, I guess I'll probably turn the question on its head and ask, what's the problem deploying everything every time? There's no overhead.
And on the other side, see, on the other side, what I've seen is, for example, I've been using CloudFormation templates to deploy my code. It keeps on track, right? What is the changes that are there in this particular deployment. So it's not going to run the whole, it's going to scan the whole template, but it's going to deploy only the changes, which are happening, which which is done, within the last deployment that we did. So it's gonna keep track what kind of changes we are doing.
Yeah, yeah.
So we've got next.
Code.
Yeah, and can we take question from Sri? He's saying, I'm new to serverless and I'm pretty habituated using the IDE. Okay, IDE debug while developing. What do you suggest while working on the serverless and I can't have a local server?
So you don't. So for example, if it's a Lambda function specifically, that is trying to. When you say debug, I guess you mean you want to step into the code and step through it. If that's the case, you can still do that. I do that quite a lot. For example, using the server framework, you can invoke the function locally. You can attach the debugger against the server's runtime, and then you can actually just step through the code. I actually got a blog post I can bring up and show it to you. 1 second.
And even here, I've shared the link. I have, like in my previous session, Eric had the same discussion. So
Okay.
I've shared the link from Amazon, which tells you that how can you locally debug your Lambda functions through your IDE itself. So they have plugins with Visual Studio Code, IDEs that you want to use, and you can simply attach your debugger through that.
That's using SAM, right?
Yep, that's
Okay.
using
Yeah,
SAM, correct?
Yeah, you can do the same thing with the server framework as well. So
Can you send me the link over?
Sure.
I'll put that up in chats because we are running out of time. We've got a few more questions coming in.
Okay, sure. So next question.
Next question is from Nishit. He's asking, what's your take on security and performance testing in serverless? Wow. Okay, good question, which we generally consider in any enterprise application delivery.
So security-wise, if you think serverless with Lambda functions, you basically have a whole class of security issues that's been taken care of for you. Anything there's any attacks against the operating system, against the server, and the whole networking, all of that is taken care of for you. And with well, not just Lambda, server applications, just with AWS application, well, any, I guess, cloud native applications in general, you should be using zero trust networking so that you don't just rely on networking to provide all the security for you. So every application should do its own authentication and authorization, and it's really easy to do that with serverless, especially with API Gateway and Lambda supporting AWS IAM, Cognito, and a whole bunch of different authentication methods. Same with AppSync, you can use Cognito, use the groups, IAM as well. As for the other side, the other part of your question, hold on, let me try and see. Performance testing. I think you should still do performance testing and load testing as well. Not so much to test the Lambda function itself, but to test everything around it. For example, you may find that there's actually a performance issue or load or scalability issue related to some dependency that your function is talking to, or it could be a case that you are testing against the DynamoDB table that haven't been provisioned properly. So you're hitting some throughput limits around that. And also with Lambda, all different services used, there are rate limits everywhere. So the load testing is also very good at identifying those misconfigurations between different services when they talk to each other. For application delivery, I'm not sure what you actually mean by application delivery there. So next question is, if you can use with serverless? Yep, you can do that with several different ways. With WebSockets, you can use API Gateway, Go WebSocket support. There's the IoT Core, which allows you to use WebSocket over MQTT. There's also AppSync, which lets you do WebSockets over GraphQL subscriptions. So you wouldn't implement a WebSocket server yourself, but you build your application on top of one of those, I guess, basic building blocks you get from AWS, and let this sort of WebSocket management side of things leave it to one of the AWS services. Okay.
So we've got some clarification coming in from Mr. Mold, I think.
Change only code, or not. So if you change only code, but we're not changing any of the, I think he meant the dependencies like libraries, and what we can do is to run as a deploy and deploy manually. Yeah. So one of the things you could do if you don't want to upload everything all the time is use layers. So you could pull all of your dependencies into a Lambda layer. and then you, in that case, when you make a change, you just deploy your code, and the layer will still be the same. There's also, if you're using the Server framework, there's also a plugin called Serverless Layers. So exactly what it does is it compares the dependencies you have in your application, and if the dependencies change, then you publish a new version of the layer, so that when you publish your code, it also references the new version of the layer first. So you kind of manage all of that for you without you having to have a separate process for managing the deployment and rollout of your layers. Let's see.
And yeah, one question from my side.
Mhm.
Question coming in from Sri. He's asking, "What's your take on serverless versus Terraform?" Then I'll take my question.
Sure. Serverless. So I would say if you can, Terraform. With Terraform, it's just it's not a very productive tool for using with service applications. If you look at how much code you have to write to provision a simple API with Lambda, you're talking about hundreds lines of code for Terraform versus about 3 for the Server Framework or SAM. And also with Server Framework and SAM, you get a lot of other tools out of the box that you don't get with the Terraform. So Terraform is basically just looking at everything as a resource, as the infrastructure pieces that you configure, which is fine if that's how you want to look at things. But with SAM and the Server Framework, certainly you can look at them more as an application, where I care about just the component of needing an endpoint. I don't care how I should provision that. Why should I know that to provision the endpoint, I need to have API gateway resource, API gateway endpoint, and then a method and integration, all of that. So all of that sort of complexity is managed by frameworks like the Server Framework and SAM that's more geared towards people that are building service applications with Lambda and other resources and other services.
So next question, Anvit. Anvit, the question that you have, it's more suitable to our next talk, because we are going to talk on DynamoDB, and we are going to have Alex, one of the reference that Yan gave us. So we are going to talk to him next week. So probably when it comes to designing databases for serverless application, I think we'll take this question next week, because we are running out of time. Let's take last questions from Gunny. He's asking, is it good to call a Lambda inside a Lambda?
Usually, well, I guess it depends. So if you're talking about, say, microservices, where you got different services owned by different, say, teams or different developers, I wouldn't go to straight from Lambda to a Lambda function. But if you're talking about within the bounded context of a microservice, where you just want to have some kind of separation between two different functions. For example, I've got an API function that handles that receives a request, but then it's going to do some background processing. I don't want to do that in the sort of user-facing path. I want to just give it to somebody else to do in the background asynchronously. Then I could go from API Lambda function, calling another Lambda function that's going to actually do the business logic, and then maybe save the data in the database somehow later. So for that, I think it's okay. But when you're crossing different boundary contexts, the microservices boundary, then you shouldn't know from your service what is the name of the Lambda function in someone else's service. So in which case, typically you go through either APIs. So the other side will have the other microservice will have its own API endpoint that you can use, or maybe go through some kind of a message queue like SNS or EventBridge or SQS or something like that.
Thanks for the answer, Yan. See, before we conclude this session, one last thing which you have mentioned in your talk, and it's gonna probably be very important for anybody who's starting new with serverless, is the limitation that we have when it comes to designing, like deploying number of resources in single stack. That is 200, right? So what is your recommendation? For example, if I'm designing a product right now, should I try to create nested stacks from the day one itself, thinking that I'm going to be there, someday down the line, right? So should I plan for the nested stacks from day one itself, or we start with the default structures, and as and when we need it, we need to create the nested stack. What's your take on that?
I think you always start with the path of least resistance. So don't start with nested stacks unless you know for sure that in the 3 weeks time this thing is going to have 200 resources, which in some cases I do, but in most cases I don't. So I don't start with nested stacks, and that's a great thing with things like the serverless split stacks plugin, that it just does that for me. I didn't have to change any code. I just brought in the plugin, and the plugin did the migration for me.
Oh, that's good to hear. I've never used that serverless split stack. I'm gonna try that out. You know, because that's something that we are envisioning that we might reach there soon enough. Okay, so I think we are good with all the questions, and we are about to end our session. So Yan, thanks again for spending time with us and giving all the knowledge that you have. And I'm gonna be calling you again for some more exciting talks. So thanks a lot, and thanks a lot to all the community members who's joined us today and showed this.
Yeah, thank you for inviting me.
Thanks a lot, guys. I'm gonna end here and see you again next week. And please, guys, don't forget to like this video and subscribe us, because I've seen a lot of views coming in, but 70% of our audience doesn't go back and subscribe to this channel. So if you do subscribe to this channel, you're gonna see all the notifications of all the new and exciting sessions that I'm gonna bring, on our community page. Thanks a lot, guys. Bye bye.
Bye bye.